Hi, today we're going to look at ways to prove that quadrilaterals are parallelograms. What we talk about today is going to be very familiar to you if you looked at what the properties of parallelograms are. The difference is that when you knew something was a parallelogram, you could talk about the properties. For example, the opposite sides are congruent and parallel, and the opposite angles are congruent. You would know that information based off of the diagram being a parallelogram. What we would look at today is all we know is we have a quadrilateral, just a four-sided figure, and some more information about it. And we need to determine if that's enough information to say that it is a parallelogram. There are 5 ways that we can use. The first is just the definition of a parallelogram, which says that both pairs of opposite sides are parallel. Now, they won't always be marked parallel. We might have to use alternate interior angles or same side interior angles to say that they're parallel. But once we've established that both pairs of opposite sides are parallel, then we can say that we have a parallelogram. The second way is to find out that both pairs of opposite sides are congruent. The third way is to find out that both pairs of opposite angles are congruent. The fourth way is to prove that only one pair of opposite sides are both congruent and parallel. And the last way is to show that the diagonals bisect each other. So like I said, a lot of those sound familiar because we already talked about those as properties of parallelograms. But now we're actually proving that a quadrilateral is a parallelogram, not using just the properties. Right, if we take a look at these 6 examples, we have to determine if the quadrilateral is a parallelogram. For number 1, we do have one pair of opposite sides congruent. And since we have these 2 angles marked, if we look at those, they would add up to 180, which means they're supplementary. And they would be same side interior angles. So that would make these sides parallel as well. So this is a yes. And that would be, we have one pair of opposite sides that is congruent and parallel. If we take a look at number 2, we have one pair of opposite sides that are congruent. We have one pair of opposite angles that are congruent. Now you may be thinking, well, I can just add these and subtract from 360 and divide by 2. Well, it's not that easy because we don't know if these 2 are the same, because we don't know if this is a parallelogram. If we started out knowing it was a parallelogram, then we could do that. We have no way of knowing what these 2 angles are. We have no way of knowing what these 2 sides are, and we don't know if any of the sides are parallel. So this is a no. We can't say that that quadrilateral is a parallelogram. For number 3, I see that the 2 diagonals are both bisected based off of the congruent mark. So this is a yes, and that reason is that the diagonals bisect each other. For number 4, this one's pretty easy. We have 2 pairs of opposite sides that are congruent. So that's a yes, because both pairs of opposite sides are congruent. For number 5, we know that we have one pair here of parallel sides. We can look at these 2 sides. We do have alternate interior angles that are marked as congruent. So if we have alternate interior angles congruent, we can say that the other pair of sides is parallel. So this would be a yes, and that would be the definition of parallelogram. Since we have both pairs of opposite sides parallel. And for number 6, number 6 kind of is a little bit like 2 with those angles on the inside. We do have one pair that is congruent, that is 60 degrees. But unlike 2, where we didn't know what those other 2 angles are, we do have that third angle, and we know that all quadrilaterals have to add to make 360 degrees on the inside. So if we add 60, 120, and 60 and subtract, we are going to get 120 for that angle. So this is, yes, it would be a parallelogram, and that's because both pairs of opposite angles are congruent.